Question 5. A water container has sloping sides as shown in figure 5.1. The water is filled to a depth of 15 cm and the water in the container exerts a pressure on the base of the container as shown over here. Question 5a, define the term pressure. This is a very standard definition question. So pressure is defined as the force acting per unit area. Okay, moving on to question 5b part I. The density of water is 1000 kilogram per meter cube and the base area of the container is 3 meter square. First, calculate the pressure exerted on the base of the container due to the water. So if I can see that there's a keyword here, pressure due to the water, you should be able to identify that the pressure formula that we'll use would be pressure will be equals to the height, rho, which is density of water, times the gravitational field strength G. So from here I can substitute in values. The height of the water is given in cm, but when I use this formula I need to convert this to the SI unit of height, which is meter. So this will be 0.15. The density of water given is 1000 kilogram per meter cube. And the gravitational field strength we know is a constant of 10. So therefore, the pressure exerted by on the base of the container due to the water would be this value. If you calculate this out correctly, you should get 1500 Pascal. Question 5b part 2. The pressure calculated in part BI is caused by the weight of the water exerted over the base of the container. So we can, from this question here, we can identify that this weight over here is a force that's acting on the base of the container. So by a pressure formula that we have also learned before, pressure is equal to force over area by the definition of pressure. And in this case over here, the force acting on the base of the container is the weight of water. So therefore, the force is simply pressure due to the water multiplied to the base area of the container. And from there, I can easily calculate that this would be 1500 Pascal times the base area of the container, which is 3.0 meters square. And from here, I should be able to get the value of 4500 newtons. And for part 3, calculate the mass of the water in the water container. So now that I found in part B part I the weight of the water, weight is given by mass times gravitational field strength. So therefore the mass of the water is simply the weight of the water divided by the gravitational field strength. And from B part 2, we have found that the weight of the water is simply 4500 and the gravitational field strength is 10, which will lead us to the final answer, which is 450 kg of water. And this will be the answer for question 5.